I was worried that my NES emulator wouldn't be fast enough to run on low-end machines. I already needed to turn off the sanitizer to run it on a 2015 laptop. I started adding command line options to the headless front end to start tracing on certain conditions, much like the break options. The user could choose a frame count, a CPU cycle, or a value of the program counter. First, I wrote their help text as my design document. I added trace option values to the argument struct. I made these options long only. I handled them in the getOpt loop. I had it turn on tracing based on the given conditions. I realized I couldn't enable all of them in one line of code because I wanted to let the user know why tracing was turned on. I made the code compile and verified the help text. I increased the width of the option name column. I tested the new options. It was running long enough, but not starting tracing. I logged the options that machine start in verbose mode. Now it was logging. Did I forget to recompile? Something was fishy about tracing from the program counter. The parser wasn't raising an error when given something other than a number. I reread the number parsing function's documentation. I had it detect number parsing failure a different way by checking if the end of the parsed number points at the start. Now it treated non-numbers as out of range. This benefited both break and trace options. I wanted to measure how much CPU time it was spending on PPU and sound. One way to do that is to disable rendering or disable the PSGs. I began adding 2 options to do just that. Today I parsed the options. Tomorrow I'd make them work. Sweep was still not sweeping in MD4A, and I wanted to know why. I turned off obsolete logging while looking for leads and then logged sweep updates. Again, logging was a rubber duck. It was checking bit 7 of the wrong variable. Changed that, ran it again, and sweep looked closer to correct. That knee worried me though. I checked whether Meson also had it. It was there too. Turns out that's where period divided by a power of 2 has a jump. On to disabling the PPU. A refactor of what does and doesn't happen if rendering is off was overdue. Then I added fields for whether the PPU and APU are disabled. I deleted sweep logging from yesterday that I no longer needed. I added a test for the no PPU flag. I made the refactor compile and ran some quick checks. Silly me, setting disable options before init CPU won't work. That took me a minute and 40 seconds to find. And rendering was disabled. I calculated how long it took to fast-forward emulation 10 seconds with and without the PPU. The PPU turned out to take 70% of host CPU time, whether using the sanitizer or the optimizer. This benchmark won't work for games using a raster effect. I had no APU mode not clock the tone generators. The length counters and sample channel would still run. I ran the benchmarks again. The APU wasn't using nearly as much host CPU time as the PPU. Maybe this is because the APU only runs at 1/6 of the speed. An NSF file is a simplified ROM with only a sound driver, no game logic, no graphics. In the 2000s, people used to rip games music into NSF files and play them with plugins for Winamp or render them to MP3. Game publishers took down ROM sites but largely left NSF sites alone. One thing I could do in the future was add an NSF player like FCEUX and Meson already have. I drafted an implementation plan to add this. NSF uses a different header and 4 kilobyte program banks, which are smaller than those of almost all cartridge mappers. Because NSF lacks graphics, I'd need to add a visualizer. If you want to see me add NSF to family size VM, let me know in the comments. Up next for tomorrow, nonlinear APU mixing. There was one thing left in APU emulation, nonlinear mixing. The NES CPU has 2 audio output pins, one for pulse channels and one for triangle, noise, and samples. So far I'd just been adding them, which gives okay results. However, the NES control deck is a cost-constrained children's toy. Its circuit to mix the 2 outputs adds a bit of distortion. In particular, when the sample channel is closer to its maximum, triangle and noise channels become quieter. A few games use this as a crude volume control for the triangle. FCEUX and several other emulators approximate the mixer with a lookup table on the output. This approach makes samples maybe 9% too quiet. I briefly considered alternate approaches before I concluded that players won't care and use the ordinary lookup table. I translated the conventional lookup generator into Python so that I could make a preprocessor. My target platform C compiler isn't new enough for constexpr. I looked up how to avoid dividing 0 by 0 because Python certainly wasn't going to apply L'Hopital's rule for me. Pulse waves are also mixed non-linearly, but it's a lot harder to hear outside certain games. This Python program's output was the input to a C compiler. I saved it and added a docstring to the top. Python is a dynamically typed language. This means any variable can hold any kind of value. A wrong program ends up doing something instead of failing to compile. That looked better. Now to make sure the wave doesn't clip. I added the table generator to the build process, declared the table in the APU's internal header, and replaced the linear mixer with the table lookup. I ran MD Fourier with the new mixer, and I could hear the volume decrease in the nonlinear mixing test. I checked the new mixer's volume relative to other emulators. It was up there with FCEUX with less headroom for expansion sound. I decided to port the anti-aliasing downsampler to the SDL front end. It wouldn't be quite perfect because it'd have to follow the sound card's preferred rate, so it'd still need to use the Bressenham timing algorithm. I made it compile, and I needed the optimizer. It still wasn't right. I added logging. That sounded good for the day. With only a week left before Hedgehog Day, I needed to add a menu to the SDL front end. I'd need a way to show a ROM file picker on both Windows and Linux. A few posts recommended a library called Tiny File Dialogues by Guillaume Vallet. I apologize if I mispronounced. I also needed a font to draw menu text. I reused this one from a music player for Game Boy Advance that I made back in 2005. I converted it to a compact tile data format. I looked to Sameboy, a Game Boy emulator by Léon Khalfon, for inspiration about the menu structure. I didn't end up adding all those features. I was about to shift gears to add menus to the SDL front end, but 100th Coin, developer of the broad spectrum test ROM accuracy coin, wanted a trace log of how one test was failing in family size VM, so I added a more flexible way to pass buttons to the machine, one that could navigate a test ROM's menu. I was reading about new string processing functions set to be added to the next version of C. I listed a few that I'd possibly end up needing to polyfill and put those on my back burner. The immediate reason I might need strdupe dealt with the lifetime of value strings in the option parser. I wrote the help text for button press sequences. It would read a string of what buttons to press, how long to hold each of them, and how long to wait before the next. I was about to change the press option, but first I needed to reassure myself of optarg's lifetime. I read the source code of muscleGetOpt, the parser I was using. Fortunately, the lifetime appeared to be the same as argv. I conditioned out the old button name parser and changed an argstruct field from an integer to a string. I started on an iterator over presses with an API inspired by string to long. Skip initial spaces. Return wait time is in frames. The CPP reference site was taking minutes to load that day. I added a doc comment describing what this routine accepts. If not a digit, treat it as a one-letter button name. Z for the select button is inspired by the N64's button order. I emitted an error message for buttons I'd never heard of, added more detail to the documentation, updated the press notice in the verbose header. It no longer waited a static 2 seconds before pressing. I needed to keep the countdown in a separate variable and rewrite all of the headless front-end's input logic. I made a half-hour's worth of code compile. The rewrite added a bug with the frame counting. I fed several press sequences to Pentley Demo ROM. The presses changed what song was playing. I played around to find the steps to get accuracy coin to freeze on a test called implied dummy reads. Whether it froze depended on exact press timing, possibly some cycle or frame parity thing. I had a button press sequence to try. I added a wait time and release after each press. The headless emulator got into the frozen state. I put displaying remaining presses behind verbose mode. After an hour, I had the 59 megabyte log that 100th Coin asked for. Fortunately, a little over 4 megabytes once compressed.